Hello and welcome to Part 2 of Construction Scheduling, Developing the Network Schedule, a Tech Training LLC presentation. Typically, when we give this course in a face-to-face environment, people are beginning to twitch in their seats and get a little anxious. The reality is that nobody can wait to jump into the network schedule. The forward pass, the backward pass, float times, and lag times are certainly the exciting part of network scheduling, if there is an exciting part to network scheduling. But the reality is, as Aristotle once said, well begun is half done. And therefore, in order to prepare our network schedule, we must first prepare our activities. So, without further ado, let's go ahead and get started. Now, as we discussed in Part 1, one of the most common types of construction schedules is the network schedule. This is most likely the type of model that you've seen on job sites or you might have seen in other classrooms. But one of the most important things about the network schedule is the actual development of it. There are many different ways to develop the network schedule, but much is going to depend upon the experience of the people who are preparing it and the people who are going to have to work with that schedule. Much like the phrase measure twice, cut once, a network schedule is of absolutely no use unless it was prepared properly. If someone rushes through the preparation of a schedule simply to have a schedule, they have most assuredly created something that's going to slow down production on the job site. In fact, they're probably better off with no schedule rather than have a schedule that is completely useless. So let's talk about the steps required in preparing the network schedule. Listed here are the steps involved in creating a network schedule. Now, just to be clear, these items are listed in order, but depending upon the project, some of these items are interchangeable. As an example, steps 2 and 3 would most likely be performed simultaneously. Also, the process of developing the schedule may continue throughout the entire construction process. For example, activity durations may change based on bad weather, labor strikes, and a host of other issues that may arise during construction. What's being shown here is a formula for building the network model type schedule. So, let's take a look at some of the details of these steps. Now, step 1 is defining the activities, and this is going to be the first thing that we do. Anything that has to be done by anyone on the construction site is considered an activity. So let's start by looking at production and construction. These would be activities that are directly related to the actual construction of the facility. These activities are easily understood by everybody on the construction site, such items as building a foundation, framing, and such. However, here we still have to be careful. Let's consider an item such as placing concrete. The concrete placement itself is only going to take one day, but time is of the essence. Can we use the concrete the next day to set up equipment on? Absolutely not. But here we must still consider our most important resource, and our most important resource is time. Now, when we consider time, we have to remember that there are calendar days and there are working days, and we have to know which to apply to what. As an example, carpentry or placing a foundation would be listed in working days. But if we consider our concrete scenario, concrete needs time to cure, and typically that cure time is 28 days. And obviously, concrete is not going to be taking the weekends off. Therefore, that must be listed in calendar days. So when creating our activities and understanding their durations, we must know when to apply working days and when to apply calendar days. Another activity that has to be considered is procurement. This means getting the materials, the equipment, the workforce, and the money to construct the project. Now, though this may seem simple, you also have to consider long lead items and the availability at the local level for local labor. And what about local materials? All of these items have to be considered. Think about this. If there's a big project going on down the street from your project, where do you think the materials supplier is going to deliver? Next, tasks like preparing inspections, processing shop drawings, processing approvals, tracking funds, tracking submittals, all take time and are considered activities and/or tasks. These are items that are taken care of by management, support staff, and administrative staff, all of which have to be considered when creating the network schedule. But again, the schedule should be created as a management tool in the field. To do this, we must be clear about the activities. More specifically, which activities follow a particular activity and which activity can precede a particular activity. And just as important, which activities can be done at the same time as other activities. But putting activities in order is not necessarily as easy as it may seem. The reason activities must be done in a particular order is what is referred to as constraints. Now, even though that sounds mighty painful, the reality is without constraints, activities could theoretically all begin at the same time, and we all know that's virtually impossible. So constraints do exist in construction, and they have to be considered in order for a network schedule to be useful. The duration of a construction project is contractually constrained by the length of the specified time in the contract documents. So there are time and contractual restrictions, safety restrictions, productivity restrictions, financial restrictions, and regulatory restrictions. But when you are initially defining a network, you'll want to minimize the amount of constraints that you introduce into the network schedule. This is because the introduction of excessive constraints in a logical order of activities can greatly impact the project. It will reduce the schedule's flexibility. It will also lengthen the project duration. It can increase cost, and worst of all, it can confuse the basic scheduling logic, which is going to confuse the people trying to use the schedule to begin with. So now, let's go ahead and take a look at the diagram of a simple network schedule. This is what a node would look like in a simple network schedule. It's a box, and at the top is listed the activity. In this case, it is activity A. Now, right below that is the duration. The duration for this activity would be 1 day. Again, typically, in the network schedule, durations are days, and then it's up to you to determine, are they calendar days or are they work days? Now at the very bottom of the node, you see 2C, 1L. This is the resources. In this case, it would be 2 carpenters, 1 laborer, working on this particular activity. Now in the upper left-hand corner of your screen, you see another node. This is simply a key identifying what each box represents in the node. So if we go across the top, we begin with the upper left. It says ES. This means early start. Next is DUR, duration, and then LS, late start. In the lower left, we see EF, or early finish, FF, free float, TF, total float, and LF, late finish. And again at the bottom is resources. Now when we do the forward pass and the backward pass, we will be filling in all of this information. But for now, let's stick to the logic of the network diagram. So again, this is activity A, and now we're going to introduce activities B and C. And what this network diagram is telling us is that activity B and C can begin simultaneously as soon as activity A is complete. Activity B is going to take 4 days, while activity C is going to take 2 days. Both of these activities are also going to require 2 carpenters and 1 laborer. Now, as soon as activities B and C are complete, we can see that a whole host of other activities can begin. Activities D, E, F, G, and H. But if we look closely, activity D and E are dependent upon activity B, but they are not dependent upon activity C. Activity F, G, and H are dependent upon activity C. However, activity D and E are not dependent upon activity C. We can also see the duration for D is 1, for E is 4, for F is 3, for G is 4, and for H is 2. And we can see the amount of resources required for each activity. So now we're going to go ahead and fill in the rest of this schedule, take a look and see if you can see which activities are dependent upon other activities, and the logical sequence of each activity through to the completion of the project. Now there'll be just a slight pause, and then we will describe the overall network schedule. So once activities D, E, F, G, and H were complete, activities J and L could take place. But as you can see, activity J was only dependent upon activity D, but activity L was dependent upon activity F, G, and H. In other words, all 3 of those activities had to be completed before activity L could begin. Now the next activity is activity K. Activity K could not begin until activity J was complete, as well as activity E was complete. And lastly, activity M, which was the final activity, which could not take place until both activity K and L were complete. Now we hope you see the logic here, but what is important is that each of these activities takes time, and there is a logical link between each activity. So the key to a network schedule is not only the logical sequence of the activities, but assigning the appropriate durations. So let's take a moment and talk about how durations can be determined. Now, as we just said, determining the appropriate duration for each activity is probably one of the most important parts of creating the network schedule. Durations are the estimated time that it's going to take to complete a particular task or activity. But depending upon the schedule that we're putting together, we have to put each of these durations into a particular unit of time. Again, in most cases, it's going to be days, and when we are referring to days, in most cases, we're going to be referring to working days. So in many cases, what a scheduler will do is tie the estimated time to the estimated costs through calculations. As an example, the quantity of work divided by the crew hours will equal the total crew hours. Or an easier format is simply take the total crew hours divided by the hours in a day is going to give you how many days a particular task is going to take. To emphasize this technique, let's go through a couple of examples. So here's our first example. Let's assume that scaffolding has to be constructed on all faces of an 8-story building for a major renovation project which is going to take place. The surface area of the building has been established to be 576,000 square feet. Historical records from the company show that for this type of structure, the production rate for erecting the scaffolding is 0.002 hours per square foot of building surface area. 10 workers working 8-hour days are assigned to the entire scaffolding project. If each worker is earning $45 an hour, what is going to be the cost of the scaffolding project, and how many working days should be assigned to this activity? If you want to pause the video and try to do your own calculations, feel free, and we're going to show you the solution on the next couple of slides. So here, the first thing that we want to do is determine how many hours are required to erect the scaffolding. Well, we know that the surface area of the building is 576,000 square feet, and we also know the production rate of 0.002 hours per square foot. So if we multiply the 576,000 square feet by the 0.002 hours per square foot, we wind up with 1,152 hours required to erect the scaffolding. Now if we take the 1,152 hours and multiply it by the $45 per hour that each worker is going to get, the estimated cost of erecting the scaffolding is $51,840. The next step is to determine the amount of hours required per worker. Well, if the total project is going to take 1,152 hours and we have 10 workers, each worker is going to put in 115.2 hours. And lastly, we want to convert our time to days, in this case working days. Each worker is going to be working 115.2 hours. We want to divide this by the 8 hours per day that they'll be working. Gives us 14.4 days. But the duration that we're going to assign to this activity is going to be 15 days, rounding it up from the 14.4. So let's go ahead and try another one. 4-inch by 4-inch tiles are going to be installed at a rate of 72 per worker hour. These tiles are to be installed in the vestibule of a large apartment complex. The area that's going to be covered is 60 feet by 60 feet. If 4 workers are assigned to this activity, each earning $75 per hour, what is the cost and the duration that should be assigned to this activity? Again, if you want to pause the video and try this on your own, feel free, and we'll show the solution in a moment. So here, the first thing we want to do is determine the number of tiles to cover 1 square foot. And the answer is 9 tiles per square foot. They're 4-inch tiles, so it would be 3 in each direction. Next, we have to determine how many tiles are required to cover the vestibule area. Well, the area of the vestibule is 60 feet by 60 feet, which is 3,600, times the 9 tiles to cover 1 square foot. Tells us that 32,400 tiles are required to cover the area. So now that we know how many tiles are required, we can determine the worker hours as well as the cost. To do this, we're going to take the 32,400 tiles and divide it by the 72 tiles per hour. This equals 450 total hours. This is if 1 worker were performing the task, or 112.5 hours for 4 workers. Now, if we take the 450 hours and multiply it by the $75 per hour that each worker is earning, the cost of the project is $33,750. And again, lastly, we want to determine the amount of working days required for this activity. So each worker is going to work 112.5 hours. They'll be working 8-hour days, which gives us 14.06 days. And again, even if we're even slightly over, we're going to move up to 15 days for this activity. Now, in those examples, we had historical data, and historical data is the best way to make a determination on a duration. Many successful GCs will employ the same people over and over again because they know how long it's going to take them to perform a particular task. And if a GC is confident in a time and cost estimate, then the GC becomes more profitable. Now, when you're assigning durations to a particular task, you are also assigning people, and therefore it is critical to have a clear description of the relationship between the critical path activities and the units of work or phases of work which have been estimated for the project. And this leads us to early start, early finish, late start, and late finish. Early start is the earliest time that an activity can begin based upon the schedule. Early finish is the earliest time that an activity can be completed. Though this may seem like common sense, the early finish time will tell us the overall project duration. Late start is the latest time that an activity can begin and still finish without impacting the overall project time. And lastly, late finish is the latest possible time that an activity can be completed without impacting the overall project duration time. Other calculations that will be done in the network schedule include free float, total float, and lag time. Free float is the amount of additional time you have on an activity before it impacts the next activity. Total float is the amount of time that you have on an activity before it impacts the overall project schedule. And lag time is the amount of time that you have in between two activities. Now, when an activity's start date is said to be fixed, it means that it has no float. These are the activities that you're going to find on the critical path. This means that if this activity has any delays, the overall project time will also be delayed. And so, as you can see, any extension of time on any of the critical path activities will equal the same extension of time on the project. And ladies and gentlemen, we will be going through all of these calculations and then some in Part 3 of Introduction to Scheduling when we create the network schedule. And ladies and gentlemen, this is going to conclude Part 2 of Introduction to Scheduling, Developing the Network Schedule, a Tech Training LLC presentation.